Alright class, this is number 44. We have 4 points to plot here. The first one's tough to see because when you plot it, it looks like it's going to be really close to the origin here, and obviously it's not. It's at 1, 1, 1. So that's A. B is at 2, and if you exaggerate these distances a little bit, it might be easier to see where these points all lie. 2, 3, 1, 2, 3, 4. Put B right there. C is at 6, so that would be, I guess maybe I exaggerated too much because that would be way out here. We'll put it. And then D would be, I'd say right here. Alright, so this is the orientation I have for A, B, C, and D. It looks like one corner of this parallelogram would be AC. Another side, I guess, more side than corner, would be A to B. So what I'm going to do is find the vector from A to C, and I'm going to find the vector from A to B, and I'm going to do the cross product of those two vectors, and then the magnitude of that turns out to be equal to the area of this parallelogram. If I had drawn it a little better, but it'll be the area of this parallelogram. So first I'm going to find the vector from A to B. A would be the initial point, B would be the terminal point. So I'm going to take B and subtract it by A. If I do that, B minus A, I get 1, 2, 3. And if I take C minus A to get this vector, it'd be 6 minus 1 is 5, 5 minus 1 is 4, 2 minus 1 is 1. So again, I'm going to try to find the vector here from I, J, K. I use a negative J because it's in this spot here. Plus, minus, plus is the top row. So for the I, I'm going to take 2 times 1 minus 3 times 4. 2 times 1 is 2. Minus 12 would be negative 10. The J would be 1 times 1 minus 15. So 1 minus 15 would be negative 14. And then the K would be 1 times 4 minus 2 times 5. So 4 minus 10 is negative 6. So here's my vector, 10, 14, negative 6. Now the magnitude of this vector is going to be the area of this parallelogram. Okay, so it's going to be 10 squared plus 14 squared plus 6 squared. If I did my numbers right, they seem a little big. I wonder if I'm right. Yep, that's right. Okay, so if I do this, I get 10 squared plus 14 squared plus 6 squared. I get 332. Square root of 332, well, I just divided it by 4, and I found out that square root of 332 is the same as the square root of 4 times the square root of 83. So my parallelogram then would have an area of 2 square roots of 83. Alright, now the second part of the question is determine if the parallelogram is a rectangle. We have a formula for that. Cosine theta equals u dot v divided by the magnitude of u, magnitude of v. But we don't have to go through this whole process because the only question is this a rectangle? Is this object a rectangle? And if it's a rectangle, that would mean this angle is 90 degrees. And the only way this angle can be 90 degrees is if this ratio is 0. If this ratio equals 0, then we're going to have an angle that's 90 degrees. And the only way this ratio can be 0 is if u dot v is 0. So we're just going to take a quick dot product. 1 times 5 plus 2 times 4 plus 3 times 1. If that equals 0, the angle between these two vectors is 90 degrees. And obviously it doesn't, so because they're all positive. So it'd be 5 plus 8, 13, plus 3, 16. So I'd have cosine of theta equals 16 over something down here. So this is not going to be 90 degrees. This is not a rectangle. Alright, so this is number 44. Hope it helped.